This video is going to show you how to use a particular substitution method to solve a homogeneous differential equation. A homogeneous differential equation is in the format such that the left-hand side would be an expression of the derivative dy over dx, and then the right-hand side would be another expression in terms of y over x. The reason why the right-hand side is in terms of y over x is that if we try to express the right-hand side as the sum of two terms, we will be able to see that the first term is y over x, and then the second term is 5x over x, which can be simplified as positive 5. Then we will be able to see that the right-hand side can be expressed in terms of y over x. So for this homogeneous equation, we are going to use the given substitution called y equals to vx, with the given condition y equals to 1 when x equals to 1. So firstly, let's try to look at this particular substitution method, where v can be considered as a function of x. If the right-hand side is the product of two different functions, then when we are going to find the derivative of y on the left-hand side, when we are going to differentiate the right-hand side, we have to apply the product rule, so that the left-hand side will become dy over dx. And then for the right-hand side, consisting of two terms, the first term should be dv over dx times x. And then for the second term, it should be small letter v times dx over dx. As dx over dx is defined to be 1, we will be able to have this particular outcome, dy over dx equals to x times dv over dx plus v. And then when we are going to look at the given differential equation, we will be able to see that the small letter y on the right-hand side can be replaced by the product of v and x, where the expression dy over dx on the left-hand side can be replaced by x times dv over dx plus v. So that now the left-hand side becomes x times dv over dx and then plus v. And then for the right-hand side, small letter y becomes v times x, and then plus 5x here over x. And of course, we can try to express the right-hand side as the sum of two terms, such that the first term becomes vx over x, simplified as v. Similarly, for the second term, 5x over x, simplified as 5. And then, of course, we can try to cancel the identical terms. And now we will be able to have x times dv over dx equals to 5. From the structure of the left-hand side, we will be able to observe that this differential equation can be solved by separating variables. We can try to move all the expressions of x to the right-hand side, such that the left-hand side should be having dv only, and then for the right-hand side, it should be 5 over x times dx. After this, we will be able to add an integration notation for both sides, such that now we have two indefinite integrals. And then we can try to integrate both sides, such that the left-hand side becomes v. And then for the right-hand side, we will be able to have 5 times natural log absolute x, and then plus the arbitrary constant c. As our final target is to express y in terms of x. Once we successfully make the small letter v as the subject, we will be able to replace v by y over x. And then the right-hand side should be the same, 5 natural log absolute x plus c. We can try to use the initial condition when x equals to 1, y equals to 1. So that the left-hand side becomes 1 over 1, and then the right-hand side becomes 5 times natural log 1, and then plus c. And then it becomes 1 equals to 0 plus c, as natural log 1 is defined to be 0, so that we will have c equals to 1. Therefore, we will be able to have y over x equals to 5 times natural log absolute x plus 1. And then for the last step, we can try to move the denominator from the left-hand side to the right, such that the right-hand side becomes 5 times x, and then natural log absolute x plus the last term x. And this would be the required answer format y equals to fx.